Hello students, so today we will be discussing a problem on the exponential spiral. तो जिन लोगों ने प्रॉब्लम नहीं देखा है, they can read the question, they can pause the video and then try to attempt the question, and then we'll proceed with the solution, whatever it is. So assuming that you've already attempted this question, so this is an exponential spiral जहाँ पे ये दिया गया है कि r is equal to r naught e to the power theta, which means that the position vector, मान लीजिए this is the position vector of any point on this spiral. This is theta and this is r. So as theta increases, r also increases because e to the power theta increases. Now the idea is, if we'll try to find out the center of mass of the system, उससे पहले हम एक बार समझते हैं कि मान लीजिए अगर आपके पास एक सर्कुलर रिंग या कोई सिस्टम दिया जाए, तो हाउ डू यू प्रोसीड विद इंटीग्रेशन ऑन दैट सिस्टम. वहां पे यूजुअली हम क्या करते हैं, जैसे फॉर एग्जांपल इफ यू गो एट अ सर्टेन एंगल थीटा, वहां थीटा एंगल पे जाके वी अज्यूम अ स्मॉल एलिमेंट डी थीटा, एंड इफ आई जूम इन हियर, दिस इज आवर स्मॉल एलिमेंट. सो यहाँ द पॉइंट वर्थ नोटिंग इज कि जो ग्रीन वाला पार्ट है दैट इज द टेंजेंशियल डायरेक्शन एंड द ब्लू वाला पार्ट इज द रेडियल डायरेक्शन. इन सर्कुलर these two are perpendicular to each other and this is written as r d theta. यानी वो एलिमेंट जो परपेंडिकुलर होता है पोजीशन वेक्टर के, दैट इज जनरली टेकन एज आर डी थीटा, जनरली टेकन एज आर डी थीटा. बट अगर हम एक सेम चीज अगर एक्सपोनेंशियल स्पाइरल में करें तो दैट वुड बी लॉजिकली फ्लॉड. आई टेल यू व्हाई. लेट मी कॉपी दिस डायग्राम अगेन. इफ वी जूम इन हियर एंड लेट्स से at an angle theta, we let's say at an angle theta we take an element d theta, this d theta. So here in this element which I'm marking with the blue, this element, this will not be perpendicular to this. In fact, if I zoom in a bit, so ये हमें कुछ ऐसा दिखाना चाहिए कि अगर r is the position vector, then the blue वाला displacement vector should be somewhat here, and this is the vector or the line that I'm representing with this. If this is r and this is d theta, then this blue vector can actually be divided into two parts. One is perpendicular to this green radius vector and one is along this radius vector. And these two white vectors will actually produce this blue wala vector. Blue wala vector is actually the element on this exponential arc, on this exponential spiral. This element can be written as r d theta. However, if you'll understand this element, ये ब्लू वाले डिस्प्लेसमेंट लेने में जो छोटा सा डिस्प्लेसमेंट एक हमारा परपेंडिकुलर टू रेडियस वेक्टर हुआ, वो तो हमने आर डी थीटा लिख दिया. एक ये जो डिस्प्लेसमेंट हुआ, अगर आप समझें, दिस इज इन द रेडियली आउटवर्ड डायरेक्शन, तो इसको हम लिख सकते हैं दिस इज द स्मॉल चेंज इन द रेडियस दैट हैज हैपेंड व्हाइल वी हैव टेकन द ब्लू वाला डिस्प्लेसमेंट. टू गिव यू मोर क्लैरिटी, दिस आर डी थीटा विल बी इन द टेंजेंशियल डायरेक्शन and dr will be in the radial direction. So in the case of the exponential spiral and generally non-circular curves, the element cannot be directly written as rd theta, because rd theta will be just a small part of the bigger element. That will be just one component. Let me copy this up and enlarge it for the better viewing. Just one second. Yes. Now the idea is how do we write down this rd theta and dr. We know r is given as, in the question it is given as r naught e to the power theta d theta. That will be r naught differentiation of e to the power theta with respect to theta. And differentiation of e to the power x with respect to x is e to the power x only. So differentiation of e to the power theta with respect to theta will be e to the power theta only. So that will be r naught e to the power theta into, if we try to find out dr, that will be r naught e to the power theta d theta. Let us keep that thing in mind. Now what is r naught e to the power theta? You will see this. R naught e to the power theta is actually r only. So if we'll try to understand this, dr comes to be equal to r d theta, which means that these two y displacement vectors are actually equal, and this is actually a property of exponential spiral. This is actually property of an exponential spiral. Now, if this is the property of the exponential spiral, this is the property of exponential spiral, we must know that, let's say, this blue vector can be called as dl. So by simple Pythagoras, dl square should be dr square plus r d theta square. And we know that dr and r d theta are numerically equal, because that is the property of the exponential spiral. So this can be written as r d theta square plus r d theta square is equal to dl square. So what will be dl equal to? That will be root 2 r d theta. That will be root 2 r d theta. Very, very important idea that you should have in mind. So the element length at theta angle, if you take a small d theta element, at a theta angle, if you take a small d theta element, so the element length actually comes out to be equal to root 2 r d theta instead of r d theta. That is the difference in the exponential spiral. एक्सपोनेंशियल स्पाइरल में एलिमेंट जो आता है वो रूट 2 टाइम्स आर डी थीटा आता है, आर डी थीटा आता है. नाउ मान लेते हैं, लेट्स से एक आर पोजीशन वेक्टर पे, एंड दिस पोजीशन वेक्टर मेक्स एन एंगल ऑफ so let this angle be theta. The element here will be some root 2 r d theta, and the position vector can be written in x and y coordinates also, because this is the x coordinate and this is the y coordinate. X will be r cos theta and y will be r sin theta. So let, for this wire, let the lambda be the mass per unit length, that is the linear mass density, lambda. So lambda into root 2 r d theta will be the small mass dm multiplied by its position vector. So what is the position vector? Let us pick these up. That will be r cos theta I cap plus r sin theta j cap. That will be the mass moment. I'll integrate from 0 to 2 pi, dividing by the total mass, and total mass will be lambda into root 2 r d theta, that is dm integration of dm 2 pi. So here lambda and root 2 will get cancelled out. We can substitute r to be equal to r naught e to the power theta. Here also r is equal to r naught e to the power theta. Similarly here also. So the above integration will actually become integration from 0 to 2 pi e to the power 2 theta cos theta d theta I cap plus 0 to 2 pi e to the power theta sin theta d theta j cap multiplied by r naught and divide by this whole divide by integral 0 to 2 pi e to the power theta d theta. Now what do we need further here? Will we require to use a set of standard results? And those standard results are e to the power 2 theta cos theta d theta is equal to e to the power 2 theta 2 cos theta plus sin theta by 5 e to the power 2 theta sin theta d theta is equal to e to the power 2 theta 2 of sin theta minus cos theta by 5. And of course, e to the power theta d theta is e to the power theta. Of course, plus c everywhere because we are writing in the indefinite integral form. Now, all we need to do is substitute the values. These are the standard integrals. For example, the integral of this is this. And on substituting the values by writing down the integration and substituting the values, we get the final result as e to the power 2 pi plus 1 by 5 2y cap plus j cap. So that is the position vector of the center of mass. So to recall or recap, the most important takeaway from this question is this, that dl is equal to root 2 r d theta. And if you understood this question, you should try this question as well. So you can read this question and we'll discuss it. You can pause the video and then attempt this question. And then we'll start discussing this in a while. So hoping you have attempted this question. So herein a tangential force is given. The tangential force is F is equal to F naught 1 plus Ks tau. This tau t vector is the tangential vector or the vector in the tangential direction. Tangential direction. It is a tangential force. So we must recall from the discussions of the work power energy that the work done by tangential force is given as integral of F ds, where s is the distance on curve, or we can also say path length. If f is constant, this work becomes f integral ds. So this is simply f into s, that is force into the path length. But in this question, the force is not constant. It is given as a function of s only. So herein, the work will be given as integral of f ds. The expression of f is given above. That will be f naught 1 plus ks ds. So the integral of this. So the particle will cross the x-axis for the first time when the angle covered changes from 0 to 2 pi. Now let us first integrate it, then we'll put in the limits. So here it will be f naught s plus k s square by 2. Let the initial distance be 0 and the final distance be s naught. So this will be f naught s naught plus k s naught square by 2. So what is s naught? S naught is the path length from 0 to 2 pi. And how do we calculate the path length here? For that, we'll go to the previous question and we'll acknowledge the fact that this small element has the length root 2 dr cos theta. Root 2 dr cos theta. So herein, it will be S naught will be simply integral of the small path length. That will be root 2 dr theta. Now, because it is root 2 dr theta, we can substitute. Uh, 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 it will be actually equal to root 2 r d theta. So we can substitute r as r naught e to the power theta. So this will be simply becoming root 2 r naught e to the power theta d theta from 0 to 2 pi. That is root 2 r naught integral of e to the power theta is e to the power theta only 0 to 2 pi. And that will be root 2 r naught e to the power 2 pi minus 1. So that will be S naught. And we can substitute that in the equation 1. What we'll get? We'll get work as F naught, S naught plus K S naught square by 2. Substituting the values of S naught here. Let me write down the final answer in that case. And that will be root 2 F naught R naught e to the power 2 pi minus 1. 1 plus K by 2 e to the power 2 pi minus 1. So you can substitute the values and see if you get the same result. But again, the main idea is that the small element has the length not r d theta, but root 2 r d theta. In fact, in the first question, you might get the correct answer by wrong method also if you don't include this root 2 term, because this root 2 term will get cancelled in the numerator and the denominator. But in the next question, this root 2 terms become very, very important, and therefore it comes in the answer also. So I hope this gave you some insight about the exponential spiral. Bye bye. Take care.